Hello everyone, I hope you are doing well. Welcome all in this new video. In this video, I will create a machine learning model from a given dataset and I will show you step by step process for the same. So before going deep dive into video, my name is Uday Khan and my YouTube channel name is Analyst Uday. If you are someone who love data science and machine learning, then this is right place for you. You can subscribe to my YouTube channel and yeah, further without wasting any time, let's jump into the video. So I already have opened Jupyter Notebook. So I will open this browser. As you can see, I have given the title End-to-End Data Science Project for Beginner. So why beginner? Because I have not used that advanced fancy models, machine learning model. So, and also this is my first video on the machine learning model, so I wanted to have some simple machine learning models. So a brief about dataset. The dataset contain information from the 1990 California census. So although it may not help you with predicting current housing prices like the Zillow Estimate dataset. So this is another dataset that is means newer dataset. So it does provide an accessible introductory dataset for teaching people about the basics of machine learning. So that's why I included this dataset here. So total there are total 10 features in this dataset and there are total 20,640 number of rows in this dataset. So these are the columns name. The columns name include longitude and latitude positions for the house and the housing median age, the age of that house, the total rooms in that house and the total bedrooms, populations, households, median income, median house value and ocean proximity. So these are the basically columns name and the target variable name is target column name is median house value. Means we will predict the house value of that particular for the particular given this input values. So we might have longitude, latitude, and total bedrooms, total rooms, population, and all. And we will use that values to predict the house value for that particular basically given parameters. So these are the steps involved in this whole step-by-step data science project. So the first is load the data, second explore the data, third clean the data, then data visualization, then transform the data, then feature scaling, split the data, then build the model, then last one is model evaluation. So before wasting time, I will go quickly because I know you will be knowing all these things like we have to import all the necessary library before doing anything. So I have imported all the necessary library here. So we will import later if we need something else. So as you can see here, all the necessary libraries are imported. You can see I have run this cell already. So I will first clear the output of this of all these cells. So I will clear output of all these cells, so it will make more sense. So I have cleared the output. I will run the first cell. I will click on shift plus enter and it will import all these four library numpy, pandas, cbar and matplotlib. So the first cell has successfully run and the second is load the data. So I will load the data using pandas function pd.readcsv. I have given the data set. I have given the path of data set. So that is this is the path of my data set. You can give path from your own computer. So this is the data set and I have created the data frame using that housing data which I imported in this first cell. So I will run this first cell, then second cell. So You can see we have created a data frame. I will run this cell to check the top 5 rows of my newly created data set. So as you can see, there are some values for that, for all those particular columns. So we will see it later in the exclusion part. So as you can see, I will check this data frame which I just created. The shape of this data frame using df.shape. I will run this cell. This shape is 20k 640 comma 10. Basically it has 240 rows, 20,640 rows, and total 10 columns. So this shows the df.shape. Then again I will print the columns of all this of this data frame. So total 10 columns. Then again I will check the information about my data frame. I will run this df.info cell and it will show me this result. You can notice that total bedrooms attribute has only 20k 433 non-null values, meaning that 207 distinct are missing. Basically 207 values are missing in this feature. So and all attributes are numerical except the OSIN proximity field. So as you can see here, all the attributes are float type. So these are numerical values. The last one, that is OSIN proximity, is an object data type. So it is an object data type. So since you loaded this data from a CSV file, you know that it must be a text attribute. So this is what we can understood from this object data type. You'll be able to notice that the values in this OSIN proximity column were repetitive. Basically, if you see here, like if you check some more values of this OSIN proximity, you will see that means you will see these values are repetitive, nearby, nearby, nearby. All these 5 rows are having nearby, and some more rows having some other values. So and that value may be repetitive. So this is what it is showing. So we will check how many values are there for this OSIN proximity. So we'll run this cell and you can see there are total basically 9,136 values for OSIN, 1H OSIN, then inland having 6,551 values. Similarly, near OSIN is having 2,658, nearby is having 2,290, and Iceland is having total 5 values. This is what I was saying, like these OSIN proximity values are repetitive. So the next cell is df.isNA.sum. So it will show us like is there any null values in this df data frame. As you can see, this total bedroom is having total 207 null values, which we already discovered here. So we will see it later. I will check the data types for this data frame. As you can see, the OSIN proximity is having object data type. I will describe this data set. So to check this some statistical values for this data frame, you can see there are total 20,600 count for this longitude columns, longitude feature, and then same for the latitude, and same for the median is total rooms. But the total bedroom column is having 20,433 count. This basically this clearly means it has some missing values, and the rest of the values are having same. So we will see and we will clean the data in the next step. So next step is clean the data only. We have already discovered that total bedroom is having some missing values. We will fill that values by the median of that total bedroom column. So we will basically calculate that median of that total bedroom column by using this df total bedrooms dot median function. So that median gives us the median of that column. So we will store in a in a variable called med. So we will then fill this all these missing values with that variable, with that value, med value. So we'll run this cell and we will check the median value of the total bedroom column. So it is having median value as 435. We can use mean also, no issue, but I will prefer median here. So 435 is the median. I will fill this the missing values with the median value. Then I will run this cell. So you can see that dot fill any function methods fills the NA values with that median value. So now if we check that df dot is NA dot sum is having any values or not, so it will show us, it should show us the 0 0 for all these for all the columns. So as you can see, there are no null values for any of the columns in the data frame. So we have clearly filled that missing values. So we have done the cleaning part of the data frame. This data set is having very less. This data set is having almost clean the data, but we might get some data set where we have to do some more cleaning and cleaning step. So be ready for that. In the next project, I will show you how to do that. The fourth part is data visualization. So as you can see, I have written the code for the data visualizations part. So I have imported the C1 SNS. So I will use the C1 library for the visualization, and most of the time I will be using dist plot and then box plot and then pair plot and scatter plot. So these are the top basically uh, plotting method for plotting any data. So I will use those. So if you want to basically visualize any particular column, so we will give that column's values in the as the attribute here in the dist plot. So I have done this KD value as true. I have put the KD value as true and beans is equal to 20. You can change this value according to your basically uh, desire. So but I think this looks pretty good. When I run the cell, you will see how the plot is going to look like. So see, this shows us the KD thing, and then the dist plot is showing us the values for that median housing median is. So the data is clearly distributed over all this all the uh, for all the age like 0 to 50. So most of the uh, basically house are having their is between 20 between 10 to 40 or 45, you can say. But some houses are having are basically more than 50 years, so they are 50-year-old house. So you can see I have written the second cell for the data visualization. This one's shows us the dist plot for the total rooms. I will run this cell, and you can clearly see that there are very less rooms in the houses after 500, after counting the 500. So yeah, most of the values are nearer to 0 and are between 0 to 500, 5000, sorry. And the next cell is total bedrooms. So total bedroom, in this also you can see most of the values are between 0 to 800. In fact 800 is around 500 to 800. There are so many houses whose are having total bedrooms more than 8000, in fact more than so basically this graph shows total more than there are so many houses who which are having total bedrooms uh, in between the 0 to 1000. this was the meaning of this plot. And then again households. Here also most of the houses are having household values between 0 to 1000. Then again median income of that house. So median income is between basically from 0 to, in fact I can say 8 or 6. So this was the meaning of this graph. And then again the median house value is between uh, 1 lakh to 4 lakh or 3.5 lakh. So this was the meaning of this graph. And the highest is for in between, I mean 1.8 to 2.5 lakh or 2 lakhs, something like that. So we will see this later. And we will not we don't need to understand all these values. We just need to check the outliers, all that things which might impact our model, machine learning model. So we will not see all these values. We will only see if there are some outliers. So we will draw this box plot. As you can see, there are some outliers in the median house values, which I just did not tell you that this is also outlier, because the graph is something like this, and then in the last it is going upper side, and which should not be and will be detected as outlier. So the most of the values are between 10 point 1.2 lakhs between to 2.8 lakh. So this graph shows the exact value where most of the basically uh, median house values are lying. And then pair plot for the visualization of all those basically features which we are having in this data frame, in this data set. So it will take some time. My basically laptop specs are not that much good that it run in a second. So please wait a second. uh, Not a second, I think it will take some more time. Okay, so fine. uh, as you can see, there are so many pair plots for the respective uh, mm, features. So I will not go into detail of these features because it will take so much time. But you can see that the the latitude and the longitude values are between, like there are some values which are having latitude in between 120 to 122. Then there are some houses where latitude is having 118 to 116. So all those things you can basically go through in the detail, but I don't think it is needed. So then again the next plot, that is the multivariate plot. I have basically taken total rooms and total bedrooms and median values. So I will run this cell and I will uh, plot the scatter plot here. So wait a second. Again, you can see. So total bedrooms and total rooms are at the y and x axis, and the median values of those basically houses are median house values of those houses are here. So as you can see, the median values are basically uh, higher where this circle is darker. So the darker means this is the darker. So if total rooms are almost 30k and the total bedrooms are almost 4k, then your chances are high that your house value is more likely to be 5 lakhs, and larger than more than 5 lakhs also. And here also, as you can see, if your house is having total rooms approximately 18k, and the total bedrooms are more than 5k or in between 5k and 6k, then your median house value is more likely to be 5k 5 lakh, sorry for the uh, so again, one more, if your house is having values, total bedrooms equal 1k, and total rooms equal 0 to 5k, then again the housing value might be lower, means nearer to 1 lakh, 2 lakh. So this is what basically scatter plot is showing us. Again, the second is I will plot the scatter plot for the median income and then median house value. So this is what it means. There are so many basically houses whose median income are between 0 to 8, and then their median house values are basically uh, I can say in all the ranges, but most of the houses median income are between 0 to 8 lakh. There are very less houses whose median income is more than 8 lakh or 9 lakh. So, yeah, this is what it means. And again, the next is heat map. uh, I have taken the correlation between the numerical value of all those numerical values, and then I have plotted the heat map function. I have plotted the heat map plot. So you can see latitude and longitude are negatively correlated, negatively highly correlated, and which are highly positively correlated. You can see this median income and median house value is highly correlated and with the positive values. So again, one more thing, population and median income is highly correlated. Households and the population is highly correlated, that is 0.91. And again, household and total bedrooms are very much correlated, positively correlated. In fact, it is the most of the all the values. So household and the total bedrooms are highly positively correlated, and again the population and total bedrooms are highly positively correlated. So this is what it means, and there are some values which are nearer to 0. Let me search. So, okay, so this value and this value also, so these values are not that much correlated, but we will keep it here only. Next thing is that we will transform the data. So again, you can see longitude and latitude are very much unlikely correlated for the median house value. Basically, these are nearer to 0. These values are nearer to 0. So we will basically drop these columns, and we will continue with the rest of the values, rest of the features. So we will drop these features here only. I will use the df dot drop, and then you can see x is equal to 1 means it will apply this df dot draw function on the column, on the column, not on the row. So I will run this cell and it will drop the longitude and latitude feature. So again, you can see if I write df dot head, so df dot head, this time you will not see the longitude and latitude column. As you can see, there are no longitude and latitude column. Now again, I will change this housing median age to the housing age only. Basically, these things we do in the transformation in transform the data part. So these things we usually do in the transformation part only. So we'll rename, we will drop, we will do some encoding also. So we will rename this housing median age with the housing age with the help of df dot rename method. Then As you can see, these three things will be renamed to their newer values, their newer name. So as you can see, now most of the things, most of the columns are in the numerical form, but this OSIN proximity is having some object data type. So we know that our machine does not understand the basically besides 0 and 1. So we will try to basically change it into 0 and 1 and then in the numerical form. So we will do with the help of one hot encoding. So it is a technique used to represent categorical variable as a numerical data. It creates a new binary column for each unique category in a categorical variable. So each row has a 1 in the column for the category it belongs to and a 0 in all other columns. This is what it means. And I will do the sessions.count for this OSIN proximity. As you can see, there are so many values for this one H OSIN category. And then the second position is having inland. Then the third is near OSIN, then nearby. The last is Iceland. So okay, so uh, first I will run this tf.get dummies. So I will get some dummy values for this uh, categorical values in the OSIN proximity column. So we'll run this cell and I will use this drop first attribute here because it what it does that it just remove the original column and keeps only that are basically uh, having the new numerical values of those categorical variables. Basically now nearby will be having some numerical value. One H ocean will be having some numerical value. Inland ocean proximity will be having some numerical value. And as I did draw first is equal to true, so the original ocean proximity column will be dropped here. So when I run df.head, you can see there is no ocean proximity column which is having some object data type. Now the newer columns are basically have replaced that one column. Four newer columns are here. So you can see why there are only four newer columns, why not five? So if all values are 0, so basically what it means, like if it is 0, it is if nearby is 0, 1 H ocean is also 0, inland is also 0, near ocean is also 0, then it clearly means that if all four are 0, then it is certainly the last one, that is Iceland. So we do not need to have total 5 basically columns for the 5 variables. So if we are having total 5 column, then we can have 4 variable. If all values are 0, then it is certainly the last one. So I will again check the df.save. So you can see our basically number of columns have been changed. So it has been changed to 11. Then again I will check for the sanity. Df is null dot sum. So as you can see, there are no null values. Okay, so the next step is feature scaling. So in the feature scaling, we will do this standard scalar. We will use this standard scalar function from the scalar.preprocessing module. So we will run this cell, and you can see uh, I have run this cell successfully. And again the next cell I will run this cell. I will run all those cell. I will basically collect all those columns which are having some numerical data. So housing is total rooms, total bedrooms, population, household income, housing values. These are the columns name which are having some numerical data. So I will run this cell, and then again I will call this standard scalar function. Then I will do the fit method on this on this numerical data frame. Then I will transform that scale data, and I will transform all those all those fitted values on this numerical data frame. I will basically transform all those scaled data frame values on the real uh, data frame. So our real data frame is numerical df and our scale data frame is scdf. So we will do the transform method, so we will get the original scale data frame. We will run this cell, this, then as you can see we have successfully run this cell. So again we will create a new data frame that is called new data frame light, and with the help of this scale data frame which we just got in the above cell. We will run this cell and we will again run this new df light dot head dot 3. I have run this cell before also, but no issue. We'll run this again here. As you can see, these are the values. So standard scalars means the values should be in between 0 to 1 for the min max, but it might goes to -1 to 1. So but you can see there are some values which are having values more than 1. So this happens when you are having some outliers. So you don't worry, this does not basically affect in our machine learning things. So these are the parts which we should go into deep dive. But in this project we will not go into deep dive, and we will just know that why it is having more than one values, more than the values more than one. So just know that that's enough. And I will new df dot I will run this df dot head. As you can see, these are our original values and these are our this new scale data frame values. So again our categorical data frame. So this is our categorical data frame. So ocean proximity inland, ocean proximity Iceland. So all those for basically categorical features of that ocean proximity column. So I will run this cell and we will basically get the values of ocean proximity. So yeah, we run this cell and I will just concat the new df light data frame and this cat data frame. As we know, these values basically cat data frame is already having values in between 0 to 1, so we do not need to basically transform this data frame. So we just concatenate the newly scaled data frame and this cat df. As you can see, there will not be any value which are having more than 0 to more than 1. Yeah, so 0 1 0 1. So all the values are either 0 or 1. We do not need to scale on this categorical data frame. So we'll run this cell and we'll see new data frame. So now this is our data. This is our data which we will use to train the model. So all the values are scaled and cleaned. So again the next step is split the data. So in splitting the data we use this train test split method from this model dot selection sklearn module. So I will run this cell and will in the x, that is our input variable, here we will drop the housing value feature from this new data frame, and rest of the columns will be our input variables, and only housing value column will be our output variable. So we will drop this housing value column, and you can see x dot head is not having housing value feature. So y dot head, it is having housing value feature. The name of this column is housing value. So this is basically input and output labels. So again we will do the splitting in this cell. So X train, X test, Y train, Y test. These are the outputs of this train test split method. So it gives us it returns four values. So we will give X and Y as input and output, and we will do test size is equal to 0.2. You can have 0.3. So basically you can have any number of values, but mostly people follow 730 or 80-20 rule. So yeah, I have also taken the 80-20. So I have taken the test size is equal to 0.2. So random state is equal to 20. You can have any values. So it does not means it does not basically affect. And yeah, I will run this cell. Then I will print the shape of X train and Y train. So there are total 16,512 rows in the X train data, and same for the Y train. And the 20% of this basically total number of rows will be gone in the test data set. So we can print those also. Copy this set. So Y test, we'll just run Y test only. So we'll run the Y test. So Y test is having 4,128 values. So this is our X train and Y train. Then the most important part is building the model. So as I said, I have not used that very big fancy machine learning model in this beginner data science project. We will use those fancy models, those heavy models for the upcoming videos. But for now, we will using linear regression and support vector regression. So these are the basically machine learning model which we can import from the sklearn modules. So sklearn.linear model import linear regressions, and then sklearn.svm import svr. So these are the machine learning model we will be using here. So I will run this cell and it will import these machine learning models. I will define linear regression as LR, and support vector regression as SVR. So I will run this cell, and the next is lr.fit. What it will do, it will train our model, machine learning model, that is linear regression model, on the train dataset. So train dataset means the output will be Y train and input will be X train. So as soon as I run this cell lr.fit X train comma Y train, it will train our model, linear regression model. So as you can see, the output is linear regression model. So again, I have here declared the support vector regressor as SVR. So we'll run this cell. It will define the support vector regressor as SVR. Then I will fit this SVR, that is support vector regressor machine learning model. So as soon as I run this cell, it will basically fit. It will train our machine learning model, support vector regression model, on this X train and Y train dataset. So I have run this cell also. It will take some time. You can see this is basically taking so much time. It might not take on your computer, but yeah, this is taking on mine. This is taking so much time on mine. So both the models have been trained on X train and Y train. Time to predict the values for the X test. So I will run this lr.predict and svr.predict on this X test and X test. So it will give me this predicted values for this X test, and similarly for this support vector regressor model, it will give me the predicted values for this X test. Yeah, when this cell. So we have our predicted values in the LR predict and SVR predict. So these are the predicted values LR underscore pred, SVR underscore. So I will run this cell to show you the predicted and basically and the true values, that is y test. So y test and x test are the combinations which are having. So x test is having input values and y test is having output values. So that is the true value of that x test values, and LR predict is having the predicted values, that is that our model has predicted. So as soon as you run this cell, you will see the predicted values for this LR model. So the y test is having minus 0.77, but our model has predicted minus 0.44, and the same for this y test is having 0.7395, but our model has predicted 0.64489. So in this second one, our model is pretty close, but rest these two, I will not say close, but yeah, that has predicted somehow correct values, that the values are in negative. So it has also predicted the negative values. So I will not say that is a good model. So, but yeah, that is what we have done in this project. So it doesn't mean basically it is not necessary to have the very good model that has 100% accuracy. But yeah, you should know how to improve and do all those hyper tuning things that we will see in the later upcoming videos. Again, score, we will check the score of this model. We will run this cell. As you can see, the score of linear regression on train set is having 0.63 and 45, 0.6345, and the SBR is all is now running. SBR is still running, so just wait. Okay, so now you can see score of support vector regression on the train set is having 0.7365. Sorry. So score of 0.7365. So you can see support vector regression is having good score. And again for the test set, as you can see the score for this test set, the linear regression is having 0.6287, and again support vector regression is having 0.7358. So as you can see, support vector regression is having basically better score. The next part is model evaluation. So in this part, basically we will check how much good our model was. We'll import these basically error, mean absolute error, mean absolute percentage error, and mean squared error. So these are the error which we will calculate for our model. So LRMSE, LRMAE, and LRM. So mean squared error is going into LRMSE, mean absolute error is going into LRME, and mean absolute percentage error is going into LR underscore M. So these are the errors which we are calculating here. So these are the standard method in the sklearn library, sklearn.matrix. As soon as you in sklearn library, you have so many things to basically do. So don't worry, you have everything you need. You just have to understand the things, how to do, how to write, when and where, and some debugging skill. You will all basically understand what is the things going behind this machine learning model. And in fact, sklearn is having very good documentation. You can go through every time you need, so don't worry about those things. I will run this cell to calculate mean squared error, mean absolute error, and mean absolute percentage error for this linear regression model. and we'll print this in the cell below. You can see mean squared error for the linear regression is having 0.388, and mean absolute error is 0.444, and mean absolute percentage error is 2.40. Similarly, for the support vector regression model, so we are calculating these three for the support vector regression also. So we'll run this cell and we will calculate all these three values for the support vector also. So I did not change here. This should be support vector regression. Fine. Okay. Support vector. Okay, so this is basically, you can see support vector regression is having mean square error as 0.2765, mean absolute error as 0.3546, and mean absolute percentage error as 2.36. So a little bit good from the linear regression, but yeah, we can't say like these two models are very much good. So we will basically we can do more with this data set to have better accuracy. So you can play with this basically model and the accuracy of that model. You can change the things to get the better accuracy also. So that's it from my side. So conclusion is that in addition to simple linear regression, other options for model include rigid regression, lasso regression, decision tree regression, and random forest regression. If you will, if you wish to explore these alternate models further, then feel free to do so. So basically, you should have uh, mindset to learn more and more. Yeah. So thank you for watching till the end. I think that is a full-fledged data science end-to-end project for the people who are new in this data science field and are beginner. So please do this project as of your own. I will give the GitHub link where I will put this notebook and the data set where you can download and you can check out if you are having some issue. Thank you. Bye bye.